Hey, math friends. So our learning target today is I can compare two or more integers. We'll talk about what that word integer means in a minute. I can model an integer on a number line. And finally, I can find the absolute value. We will also define what that means throughout the course of this lesson. So let's first talk about what is this integer that we're talking about. What is an integer? So if we take a look at the number line over here, you can see very clearly in the number line that you have an established 0 located in the center of the number line. 0 is that neutral number. It's really neither positive nor negative, it centers the number system. As we move to the right, we have our positive integers, and they continue to grow to what we would call positive infinity. So we'd be moving at 1, 2, 3, 4, 5, and so on, all the way to positive infinity. Likewise, when we move in the negative direction, we would move -1, -2, -3, -4, all the way to what we would call negative infinity. So that's our number line. What you'll notice about the number line of integers specifically, or what hopefully you'll notice, is that all of those numbers are whole values. Whole number 1, 2, 3, 4, -1, 2, -2, -3, -4. You don't see any parts over there. We don't see any fractions, mixed numbers, decimals, things like that. So integers have to be positive, negative, and 0. So we take a look at our work here. Integers have to be positive, negative, and 0. Positive, negative, and 0. So some examples of integers. So now that we've kind of talked about what an integer is, thinking about that number line, well, integers have to be positive numbers, negative numbers, and 0. But they have to be whole values. We can't have any parts. So for example, -3 is an integer, but so is +3. -100 is an integer, so is +100. And as we said, 0 is an integer. Those are the things that we would say are integers. So what are some things that are not integers? Well, -3.5 is not an integer. -4.5 is not an integer. The square root of 11 is not an integer, and we'll talk more about square roots as we go. But those are the things that are not integers because they are not whole values. Okay, so integers. So let's go take a look at some integers now. Let's compare them on the number line. So how do you compare? Well, you're very familiar with alligator mouth. You've been doing alligator mouth for a really long time. Alligator eats the largest value. So we're simply going to just compare these two numbers. So we have the number 3 compared to the number 5 on the number line. So if we think about it in terms of money, $3 compared to $5, which is greater? Well, 5 is greater than 3. 5 is furthest to the right, the most positive. So we would say, well, that the alligator is going to eat the 5. The way that we read that statement is that 3 is less than 5. 3 is less than 5. Likewise, if we turn that same statement around and we say, what if we just interchange the numbers? Is it still true? Is it still true that 5 still is greater than 3? Is 5? Are we still going to eat the 5? Yeah. The statement that we make, the way we say that does change. This now becomes 5 is greater than 3. It's no longer less than. Okay. So what about negatives? How do negatives change things? So I'm going to erase some of this so that you have a better visual of what's going on. What about negative numbers? So now we're going to work to the left of the number line. How do we compare -3 and -5? So I'm going to identify those. We have -3 and we have -5. Which is greater? Which is more positive? Which one is closest to 0? So if we think about owing somebody money, we don't want to owe anybody anything. So we want to get closer to 0. So in this particular case, we would say that actually the alligator wants to eat the -3 because it's better, mathematically speaking. So the statement then would be -3 is greater than -5. And if we take that same scenario up here and we look down below, of course, we would just simply flip the sign because we still agree that -3 is better. It's closest to 0. So then it would become -5 less than -3. Okay, so at this point, what I want you to do is I want you to pause the video. As we're working through this, you don't have to write things down. I just want you to follow along because you don't have copies of any of this information. But when we get to the you tries, I want you to actually try it. You might be kind of just tapping your finger around on the screen. You might be doing some mental math. Sometimes you'll be solving a problem. It depends on the lesson that we are on. But for the you tries, I actually want you to try. So I'm going to go ahead and ask you to pause that video, try it, and then push play when you're done. So I'm going to continue on because you're just coming off of pausing the video now because you've tried it on your own. So let's check your you try statements. So I'm going to go ahead and erase what we have here. Maybe if I can get this stylus to work. I have a new stylus here, so I have to get kind of used to it. Sorry about that. My first lesson here. So what do we have? We have -7 compared to -4. Which is better? -4 sits here. -7 sits here. Which one is closest to 0? Well, -4 is closest to 0. So alligator's going to eat the -4. Less than. Same statement here, just reversed. Then it becomes greater than. Go ahead, check your work there. So let's go to the positive side. Now let's see what we have. How about +7? You're very familiar with positive numbers all the way since elementary school. +4. Which one's better? Well, you know that 7 is better than 4. It's more positive as we grow. So you should have a greater than sign there. 7 greater than 4. And then if we flip those around, of course, we flip the symbol because we still want the alligator to eat the 7. Great. I hope you went 4 for 4 in that. So take a look at how you did out of the 4 and see a little self-assessment. Where are you at? How you doing? All right, here we go. So let's move on to this idea of what's called absolute value. So absolute value has a symbol that looks like this. Well, if I can get it to work. There we go. It looks like that. It almost looks like a jail bar, like a number inside of a jail bar. That's what absolute value looks like. That's the symbol. The actual definition is that it is the distance from 0 on a number line. So when we take a look at this example here, the very first example, we see this symbol. We just are asking how far away from 0 is 4. So I'm going to just simply draw myself a line to 4. How far away from 0 are we from 4? Well, we're just 4 units away from 0. So the absolute value of 4 is 4. No big deal there. You'll notice when I write my answer, I lose the absolute value bars because I've answered the question. Those bars are almost like a question of how far. When you've answered the question, you lose the bars. Okay, so what if we go other direction and we ask that same question? What is the absolute value of -4? So I'm going to draw myself a line to -4. How far away from 0 are we if we're at -4? Now, this is where it gets confusing a little bit. Students aren't really sure how we could have the same answer, but we're just looking for distance. So we're just counting 1, 2, 3. We're simply just 4 units away. That's supposed to be a 4. 4 units away. Notice I didn't make it negative. It's just simply just positive 4 units away. So you'll notice that we have the same answer for the first two examples, and you'll notice that they are both positive. So when would absolute value ever be negative? Well, here is when we have that negative situation. So if we put 0 back on the number line, because this is really the question, is how far away are we from 0? And we take a look down here at this question. Here's my question. How far away from 0 are we at -4? So I'm going to draw my line. Well, we're 4 units away from -4. But the key is this little symbol right here, which means opposite. Now we take the opposite of our answer. So we said that we're 4 units away. But now, after we've answered this question, we have to take the opposite of our answer. So now I'm going to reattach that negative, and that is the only time we would have a negative in that situation. So what I'm going to ask you to do now is I'm going to ask you to pause the video, and I'm going to ask you to try the 3 problems on the right that are asking about absolute value. And then as soon as you're finished, I want you to press play, and I will reveal the answers. But I do want you to give it a shot. Okay, so hopefully you've had some time to do that. You've paused the video. So let's quick go over the answers. Absolute value of -5, you should be saying is 5 units away. Notice answer is positive. Absolute value of +5 is 5 units away. Notice answer is positive. And the last problem, remember this simply means take the opposite of your answer. Sorry, this stylus is kind of hard to write with. So what is the absolute value of 5? It's 5. It's 5 units away. We've already answered that. But what's the opposite of our answer? That's the only time that you would have a negative answer. Okay, so now let's combine the 2 skills of how do we compare integers and how do we compare absolute values. So this will be our last screen of the day, and then we'll just do a quick little summary of what we've learned in our work. So we're at the 11-minute mark right now. So let's take a look. We know that in our work, we have learned that this bar means how far away from 0 is -2. So there we go. That's how far away it is. Then we learned that this means how far away from 0 is +2. That's how far away it is. So if we really pull those out and think about what the answers would be, well, the absolute value of -2 is 2. Not really sure yellow is going to work there. The absolute value of +2 is also 2. Notice they're both positive because we just want to know how far away, how long is that line. Answer should be equal to. They are equal distance away. And you can clearly see that up here in our work. Equal distance away. Okay, so now let's go to the next one. How far away from 0 is -9? You should be saying, well, it's 9 units away from 0. How far away from 0 is -5? You should be saying, well, it's 5 units away from 0. So alligator eats the greatest amount. Which is greater, 9 or 5? Alligator eats the 9. Now the key is make sure you get them out of the absolute value bars before you answer the question. You gotta answer, before you answer the question, we gotta get them out of the absolute value bars. So now they're positive because they came out. Uh-oh, in this next example, I see that negative or that opposite symbol sitting outside. In fact, I'm going to do that part first. That means opposite of our answer. So if I think about -6, how far away are we? Well, we're 6 units away. But this particular problem is saying now I need you to take the opposite of your answer. And then how far away are we the other direction? So 3, here's 0. 3, I don't know why I started at 1 up there. 3. So now if we compare the two, which is greater, which is further to the right, which is more positive? Well, clearly, if this is -6 and this is 3, this is our bigger number because it's further to the right. So the symbol would be greater than. Okay, last problem together, and then you're going to try 4 on your own, and then we'll go over answers. So absolute value of -8 is 8. How far away from 0? And we're going to compare that to just the integer of 5. Notice this problem is not in an absolute value bar, so we don't have to make any decisions about that. It simply is just the integer of 5. Alligator eats the greater amount. You should be saying greater than. That 8 is greater than 5. But make sure we get it out of the absolute value bar before we make that decision. Okay, crew. So you have 4 left to do. So I'm going to have you pause the video at this point. I'm going to have you try those 4. You should be actually trying them. I know how that goes. I also have teenagers. Make sure that we're trying them. And then when you push play, then I'll go over those answers. So you should be pausing the video and giving those a shot right now. Okay, so you should have given those a shot. You should be pushing pause, and we're going to go through these. Absolute value of 4, you should say, is positive 4. The absolute value of negative 4 is also positive 4, just how far away from 0. They're both positive, equal to, grade your paper or your mental math. Absolute value of negative 1 should be 1, positive 1. The absolute value of 4 is 4. So notice I pulled both of those out of the absolute value. Alligator eats the bigger sign, so we would be eating the 4. So you have 1 is less than 4. So this next example, be very careful because this means opposites. So what's the absolute value of 7? 7. But now we need to take the opposite of our answer, so we get negative 7. And what's the absolute value of negative 8? 8. Which is further to the right? Well, let's go ahead and take a look at those on a graphing situation. So if I go ahead and graph those up there, we would say, well, where's negative 7? I don't know why that yellow always shows up. Sorry, I'm a little rusty with this pen here. Negative 7 compared to positive 8. Which is greater? Which is further to the right? Which is more positive? Well, clearly 8 is. So alligator eats the bigger number. We have a less than symbol. And the last problem of the day. Here we go. So 10 is just the integer 10. It's not in a jail bar. It's not an absolute value bar. We don't have to make any decisions about it. However, the other part of that comparison we do. What is the absolute value of negative 10 means how far away from negative 10 are we? Well, we're 10 units away. Apparently I'm using the crayon this time. You have to bear with me on this first lesson. Sorry, guys. Hopefully I get better with the stylus. 10 is equal to 10, so grade your papers there. All right, so hopefully we went 4 for 4 on that. Let's do a quick summary and then we're out. The summary for our work today would be this. An integer, we talked about what an integer is. It's negative 3, negative 2, negative 1, 0, 1, 2, and 3. All the way to infinity, both direction. Notice, no decimals, no fractions, no parts. They have to be whole values that are positive, negative, and 0. And then the last term we talked about was this thing called the absolute value, which we learned always has to be positive because, this is hard to write with, positive because it's a distance. The only time it wouldn't be is if there is this opposite symbol out front, then it would become negative. Okay, group, I hope you have a great night. That is your lesson on I can compare integers and absolute value. Have a glorious night.